Hello everyone. So, today we are going to start the topic tactile aspects of clothing comfort. In earlier topics we have discussed about the psychological aspects of clothing comfort, or overall it is psychological aspects of comfort, and then we have discussed the neurophysiological aspects. There we discussed about various measurement technique, psychophysics, laws of psychophysics. Then in neurophysiological aspects we have discussed the various sensors available in our skin, mechanical sensors, thermal sensors present in our skin. Now, in this segment of tactile aspects of clothing, what we are going to discuss here, that what are the different factors of clothing or maybe cloth, fabric or yarn which actually activates the sensor and ultimately we get some feeling. So, from here onwards we will discuss about the textile aspects of clothing comfort. So, here now tactile aspects of clothing comfort means tactile comfort sensation. So, what is that? So, tactile comfort of clothing, it is based on human sensory response to clothing material, like design of clothing, the type of material we use. So, how this textile material actually actuates our sensory responses. So, it is sensed by variety of stimuli. So, our clothing sends some different type of stimuli, that may be thermal, may be physiological or may be mechanical when actually we wear clothing, and ultimately it gives overall tactile response. So, if we see overall tactile response, now the thermal aspects we will discuss somewhere next segment. Here we will discuss the mechanical aspects of tactile comfort. So, if we divide the tactile response broadly, we can divide in two types, okay, which actually clothing sends to our body. First is prickliness, scratchiness, rubbing, this type of, or itching, this type of sensation we get. So, that gives some uncomfortable feeling, and we will discuss various aspects of prickliness, scratchiness, what are the different factors which actually controls the prickliness, scratchiness. If we understand this, then we can develop fabric of comfortable in nature. And next aspect is that it is a fabric handle related characteristics, which is actually sense of touch or pressure. So, in earlier segment, as we have discussed, that in neurophysiological sensation which we receive by our different types of sensors, the touch, pressure, this type, but effectively this sensation is received by the fabric mechanical characteristics. So, here we will discuss the what are the mechanical characteristics, how can you evaluate this mechanical characteristics, what are the factors affecting this mechanical characteristics. So, handle related characteristics, which is basically sense of touch, So, how do we perceive the tactile comfort? Basically, clothing, due to its different mechanical characteristics like bending rigidity, its extensibility, its surface characteristics, friction. So, this all these characteristics actually stimulates our sensory, that is sensors which are present in the skin. So, when these fabrics are in contact with our skin, it gives signal to the skin. So, our skin receives signal from this fabric. Suppose the fabric is rigid, it will get certain, that is our sensors get certain type of sensation. If it is rough, it will get different sensation. If it is flexible, it will get different sensation. So, this mechanical stimulation, the or different types of frictional force, it gives signal to our skin. Then those sensors present in the skin, as we have discussed, it sends signal to our brain, brain evaluates, and ultimately we perceive certain comfort feeling. So, which fabric gives better, best, actually maximum sensation? The tactile sensation, it is important for those fabrics which are in contact with our body. Although other fabrics which are not in contact with our body, those fabrics send indirect sensation. Suppose over a very soft fabric, if we wear a very stiff fabric, that will give indirect sensation, but mainly we should be very careful about those fabrics which come in to contact with our skin. Okay. So, this is very important. Now, let us see the tactile sensing mechanism. The sensory feel of clothing material is dependent on the mechanical stimuli due to pressure, frictional force. So, pressure and frictional force which actually send signal to our skin. Okay. When it comes into contact with our body and it stimulates they stimulate the various mechanical receptors. So, when the clothing material comes into contact with our body, our skin, they stimulate various mechanical receptors. These receptors, as we have discussed, they may be free nerve ending, okay, root hair plexus, Merkel disc, and all these mechanical receptors, and they are present at different layers of our skin that we have discussed. It is epidermis, dermis and subcutaneous zones. So, they receive the signals of mainly pressure and friction from the fabric and we get sensations. So, most tactile sensitive parts are basically, there are three parts of our body, those are most sensitive parts. One is the face is the most sensitive part, okay, because as we know that when we use any textile material for face wash or face say wipe or something, we need extremely soft one, because that face is very sensitive to tactile sensation. Next comes the torso, the main actually central part of our body, which extend neck to limbs, because that is very important. Here we get maximum tactile response, because area of the torso is very high. So, most of the part is very sensitive. So, we should be very careful of using clothing for this type of area, okay, because we get maximum prickle sensation, maximum itching sensation, maximum scratchy type sensation in this part. Okay. And third one is the hand. So, these parts are very sensitive and we should be very careful of selecting fabrics for this type of zones. Okay. The tactile characteristics of textile materials are basically typically these are flexibility of material, whether the fabric is flexible or stiff, that gives sense tactile sensation, whether a fabric is soft or hard, then it is whether it is a compressible or not, whether it is a rough surface texture, it is a rough texture or it is a smooth, that we get, whether the fabric is extensible or not. If it is extensible, it will give less pressure on our body. Okay. So, that gives a direct tactile sensation of our body. Frictional characteristics, whether there is it gives a rough sensation or not. So, these are the basic fabric related characteristics. We will see how to measure all these characteristics to know what type of tactile sensation it will give. Okay. So, among all these, if we see, although it may not be that much important, but we broadly if we see tactile characteristics, we first measure the widely we try to measure its softness by pressing by thumb or a finger. Okay. So, that it is a very widely used, most frequently used tactile characteristics of clothing is surface bulk. So, it is an initial tactile perception. If the fabric is not soft, then we actually whatever may be the other characteristics, we normally say it is not tactile soft, okay, comfortable, but there are other characteristics which are very important. So, how do we perceive softness? First is by squeezing with the help of fingers. Okay. So, the objective evaluation of softness or fullness can be done by compressibility. So, we can by hand we can squeeze it, but if we want to measure, if we want to compare the actual value, so we can measure the compressibility or compressional resilience. So, that we can measure, we will see how to measure. Okay. So, this can be done by compressibility and resiliency characteristics. So, if we see all those tactile characteristics, we can measure by measuring the low stress mechanical characteristics. So, what are those low stress mechanical characteristics? These are bending. So, its low stress mechanical characteristics is important for our clothing for tactile characteristics. There are two types of mechanical characteristics. One is high stress mechanical characteristics, where we actually test the fabric up to its end point, its when up to its breakage point, okay, maximum point. But here in low stress mechanical characteristics, we use very low stress to deform the fabric. So, like bending we use the low stress, very low amount of test bending stress, which actually is fabric encountered during wear state. Next is shear. Shear is nothing but it is a deformation when the force is applied in parallel in opposite direction. So, that is a shear. The fabric with low shear stress will give better tactile comfort. So, fabric should have very high shear strain with low stress. The very classical example is that if we prepare a clothing from a material which is other than textile material like polythene sheet, we can incorporate any other characteristics. A polythene sheet, if we want want a permeability in a polythene sheet, we can punch the holes If we want softness, we can make a very soft, very flexible, very soft one. We can make very good surface texture, but in a polythene sheet or any planar material, we cannot incorporate shear. We cannot reduce shear stress to a greater extent, because it's characteristic, it's a continuous material. But for textile material, its uniqueness is that due to its interlacement, the threads, the yarns can move freely. So, that is how the shear is characteristics is extremely important, which helps a clothing to actually accommodate our body posture. If we move our body, if we change our body posture, the clothing automatically takes shape with a very low shear stress. But if the shear stress is very high, so then it will unnecessarily impart pressure on our skin, and ultimately we get uncomfortable sensation. Okay. Next is the extensibility. The extensibility is extremely important, because if the low stress extensibility means if the fabric is made of very highly rigid structure, fabric is very high. So, then due to movement of our body, it may restrict our body movement. Okay. So, at least at low stress, the extensibility should be little bit high. Okay. Similarly, compressional characteristics, it should be soft enough. Then surface toughness, which is very important, which gives the indication of scratchiness. Okay. If the surface is rough, it will give it will generate high friction, and we will feel uncomfortable. So, we have to measure this low stress mechanical characteristics. So, there are various methods evolved, but two successful commercial instruments are a set of instruments, I should say, available. One is Kawabata evaluation system for fabric, KESF system. Another is the fabric analysis by simple test, FAST. Okay. Although FAST is not actually developed for measuring the tactile characteristics, but indirectly we can get the tactile characteristics of it. We will discuss each and every characteristic methods, okay, in detail. Now, the tactile characteristics and tactile response. So, fabric tactile characteristics, it is, these are actually directly related to the what are the responses we will receive. Okay. So, as far as the tactile responses of our body is concerned, these are all low stress mechanical characteristics of fabric, which are directly or indirectly stimulate the touch, pressure, roughness and other mechanoreceptors of our body. So, this if we understand our fabric low stress mechanical characteristics, we can indirectly, we can directly guess what type of actual response we will get, tactile response we will get. So, basically fabric tactile characteristics is directly related with the human tactile response. So, if a fabric is friction is high, frictional coefficient is high, then it will definitely give a roughness characteristic, rough. It will definitely actually try to pull the skin along with the fabric movement. So, give different sensation. So, we will start with characteristics which is its prickleness, which actually we cannot measure, it is not directly low stress mechanical characteristics. Low stress mechanical characteristics we can say, we can call it as handle characteristics, touch, pressure and all this. But prickleness is entirely different, which is not basically, it does not come under the low stress mechanical characteristics. Okay. It is not even friction or nothing. So, prickleness is basically which is which gives maximum uncomfortable nature if the fabric is prickly. Okay. So, prickliness sensation is one of the most irritating discomfort sensation of for clothing, which we actually wear next to our skin. So, even if we can bear a discomfort sensation of stiff fabric, or maybe a fabric give little bit higher pressure, but if fabric gives a prickle sensation, then we will feel tactile, we will feel very uncomfortable. And that we in last segment we have discussed the prickle sensation we get with the by some nociceptor. Okay. So, that so it is sensed by special type of pain nerves that we have discussed, which are present actually close to the skin surface in mainly in epidermis. Okay. Okay. So, that is and when a fabric contacts the skin, individual protruding fiber, actually a group of protruding fiber excites the pain nerves endings. Okay. And it is not it is a single fiber that we have discussed, it should be a group of fiber and it should actually act on a minimum area that we have discussed okay, in last class. So, fiber ends, the perception of prickle sensation, that for that we required combined response from group pain of nerves, okay, pain nerves, okay, group of nerves. So, it is not the single nerve, it is a group of nerves. If give signal, then we will get prickle sensation, okay, and that is actually that is given by a large number of hairs, okay, covered with a certain minimum area of cloth. So, now how do we assess the prickle sensation? So, to assess the prickliness of fabric, so we have to assess the protruding fiber, number of protruding fiber. We know that we need a certain number of protruding fibers, but how do we assess these things? So, it can be measured by measuring the hairiness of yarn used to produce the fabric and by measuring the surface hairiness of fabric. If we have measuring technique to measure the surface hairiness of fabric, then we can directly measure. Okay. But this type of instrument are normally not available to all the industries, most of the industries. For them, they can actually get the hairiness value measured for a particular fabric and then get certain idea about the prickliness sensation. So, although measurement of hairiness is not the hairiness of yarn is not the only criteria, we have to see the length of the hair, we have to see the diameter of the fiber. So, all this concept, all this information along with the hairiness value will give indication of material of a fabric which will be prickliness, will have prickliness or not. Okay. So, first we will discuss the different standard methods of measurement of yarn hairiness. Here we will discuss 3 standard methods of measurement. Okay. Yarn hairiness is in most circumstances, these are undesirable properties of any material. Okay. So, but in why in most circumstances, in some of the application we need hairiness, that some special effect we may like, some hairy effect we may like, or maybe some brushing effect we may try to incorporate to get more warmth, but in most of the cases it is a undesirable property as far as the appearance of fabric is concerned. Also it gives indication of the problem of fabric prickliness. So, we must know how to measure the fabric yarn hairiness. So, measurement of yarn hairiness actually depends on the method, type of method chosen. So, we may some one method it may give a number of hairs, another method may give total length of hairs projected. So, depends on the type of measurement. So, we will start with the method which is actually it and it is not possible to normally give a single parameter. Single parameter means it is a, if we try to measure the length of sorry number of hairs per unit length, that means that we should know the what is the length of the hair. So, that combination is required, and also that another method which gives the total length of hairs protruding above the hairy yarn surface, but this total length sometimes gives wrong impression about the prickliness. If so should we go for higher hairiness? If it may be a single fiber end of a long hair, that gives the total length of hair. So, one hair of say 10 millimeter, that gives a one hair length, another 10 hairs of 1 millimeter length. So, ultimately it gives the same value. So, 10 millimeter of hair, but if you see the prickliness sensation, these two yarns will give different sensation, but at least we get some idea about the hairiness. Okay. So, a yarn may have small number or long hairs or large number of short hairs or any combination. So, this are of any combination. So, these techniques will give us fair idea about the hairs. The problem is that then which combination should be actually given a higher hairiness rating. So, higher hairiness rating is it is a relative term. For prickliness sensation we may consider it is a lower hairiness sensation, but here the length of hair is very important. We must know the length of hairs. So, first we will discuss the yarn hairiness measurement by Charley yarn hairiness tester. Okay. So, in this method the it is a counter is there, it counts the number of hairs longer than specified length. So, that specified length is normally it is a 3 millimeter, above 3 millimeter of length, that is above the yarn surface, whichever hairs projected above the yarn surface, whichever more than 3 millimeter, it will count as one hair. Okay. And we can also measure, we can pre-select the length up to 10 millimeter, 1, 2, 3 like 10 millimeter length we can pre-select and count the number of hair. Okay. And it consists of a beam of light, okay, which is actually projected through a small actual diameter to the ultimately it is going to the photoreceptor. Okay. And in between the light source and photoreceptor, the yarn will be passing, and as a single hair is passing through in between this will actually interrupt the light sensation. So, yarn under test is run between light and photoreceptor, and as the hair pass between the light and the receptor, the light beam momentarily broken, okay, and an electronic circuit counts the number, how many time it has that it is broken, the light signal is broken. So, what it does, there is an aperture and between that, through that aperture, when the hair is moving, that will be counted. Okay. And it is only, and hair is actually present, the hairs are present throughout the surface evenly, and it is assumed that the total hairs are proportional to the number of hairs at that particular surface, okay, at the top surface. So, if it is light is projected through the top of the yarn surface. So, we cannot actually measure the total number of hairs, but it is assumed that it is a proportional. Okay. Like here in this instrument you can see the yarn, it has got two types of slots. Okay. This is the fixed yarn path. which is actually 3 millimeter, and this is the aperture. This one is aperture and through which light signal is passing, and this is the yarn, hairy yarn, and it is moving, it will move through this fixed path, and as soon as one hair is moving through this, it will count as a single hair. But we can see that it is not it cannot measure the hair in this side, opposite side or other side. Okay. Only the hairs which are actually passing through this aperture, this will be counted, and it is assumed that hairs are evenly distributed. Okay. And this slot is another slot, is alternative slot, which is actually which we can change. We can change the path distance. This is the variable distance, which can be from say 1 millimeter to 10 millimeter depending on this guide. This is the variable guide. This can be lifted upward and downward, and depending on that we can, it will measure, it will count, and this is the counter. And let us see the animation. Okay. Animation of, for the first it is for the fixed path. Now, it is moving, yarn is moving with a fixed path of 3 millimeter. Now this hair is cut. Now it is as soon as the one hair is moving through this, it is cutting, and see less than that length, these hairs are not been counted. So, any hair more than 3 millimeter length of this surface will be counted. Okay. So, this is the counter which actually count the number of hairs, which is actually which gives the indication of the hairs. This is the fixed path, and we get the count. The instrument has two sets of yarn guides. So, lower guide gives the fixed length, and the upper guide gives the variable set of length that we can measure, and total number of hairs in a fixed length we can measure the number of, we can count. Okay. And if we know the speed of the yarn, then we can convert it to the number of hairs per unit length. Okay. Now, next is the Zweigel hairiness tester. So, the main drawback of the Shirley hairiness tester was that it can measure, it can give the hairiness for a particular length at a time. Okay. We cannot get the more than one length at a time. So, Zweigel hairiness tester, it gives the value for in a single test, for a single yarn we can get hairiness at different hair lengths that it gives. So, it is from 1 millimeter to 25 millimeter length, it gives it directly gives the idea about the prickless sensation. The apparatus counts the number of hairs at a distance from 1 to 25 millimeter from the yarn edge. Okay. Suppose it gives a hairiness 2 to 3 millimeter or around that large number of hairs. That means we will have an indication that it will give this yarn, if we use for to make fabric, it will give prickle sensation. On the other hand, if it does not give say up to say 10 millimeter, here it is almost very less number, and above that, more than that, that means it will not give us prickle sensation. We can, that will be maybe used for other application, or that may create other type of problem, but at least prickle sensation we can get clear idea from this instrument. And the measuring principle is exactly same as Shirley instrument. Here again the light source will be actually momentarily cut and it will be measured, and here the typically the set, the distance is 1, 2, 3, 4, 6, 8, 10, 12, 15, 18, 21 and 25 millimeter from yarn surface. So, we will get wide range of data instead of in place of single data in Shirley hairiness tester. Now, this is the instrument. Here these are the different actually optical sensors at a fixed different fixed length, and these are the number of hairs counted. Okay. Now, as the hair moves, depending on the length of the hair, we can will get the number of hairs. Now, let us see, here is this is moving. Now, depending on the number of hairs at a certain distance, it gives the but ultimately we will get all this data. Okay. So, this way this is actually cumulative value, ultimately it gives the cumulative value of this. So, we will get this type of. So, what does it show? If we say this is the data, if we get this data, that means the more than 18 millimeter is a 5. Okay. So, more than 15 millimeter it is a 7. So, say 15 to 18 millimeter there are say 2 hairs. So, accordingly we can get. Okay. So, if we want to get the number of hairs, and ultimately we will get we can calculate the how many hairs will be there in yarn surface, we can calculate the how many hairs will be there in fabric surface per unit area, and we can get the prickliness sensation. Okay. Typically hairs less than 3 millimeter, around 3 millimeter or less than that creates problem, and with a stiff fabric fiber and fiber diameters are higher fiber diameter. Okay. So, the yarn is illuminated from the opposite side of the photocell. As the yarn runs past, the measuring station on the hairs cut the light off momentarily from the photocell. Okay. It cuts, and the instrument measure the total number of hairs in each category, and it has got a fixed speed of 50 meters per minute. So, accordingly we can calculate the count of yarn. So, there are different photocells, we can adjust the photocells based on the yarn surface. Okay. Next is the hairiness tester by Wooster, which is actually additional attachment of Wooster evenness tester, that during evenness testing we can actually attach this tester attachment for yarn hairiness. Here the measurement technique is entirely different. Here we do not measure the length of hair present, here we measure the total length of hair. It's here we measure the in earlier Zweigel and Shirley tester, we measure the number of hairs present above certain specified length, but here in Wooster tester we measure the total length of hair. So, how do we measure? We cannot measure the length of hair directly, here we try to measure the hair length indirectly, and indirectly we measure by light scattering principle. Okay. And the optical attachment is there in Wooster evenness tester, and where infrared light is illuminated on the yarn surface when it is moving through, and the infrared light which is actually moving directly, the direct light with a specified, actually it comes from an aperture, certain aperture diameter will be there. So, that light will be blocked, that particular light will not reach to the receptor. Okay. That means that if there is no yarn, light is there, the aperture will block the light. So, that will not reach up to the sensor. So, it will sense there is no light, even it will actually it will receive the light which has been scattered by the hairs, protruding fibers, that the intensity of that light will be captured, and it will give indirect sensation, indirect measurement of total length of hairs. Suppose one yarn, it is moving on filament yarn, if we move. So, as there is no hairiness, so it will not scatter the light. Okay. That it will that light will not reach up to the sensor. So, it will only receive the signal from the to those light which have been actually scattered by the protruding fibers. And so, this is the setup. Okay. So, here it is a IR transmitter, okay, and the light which is actually it is projected here, it has actually been converted to the parallel beam of light. Okay. Suppose there is no yarn. So, this is the light actually the direct light, and here it is a light stop arrangement. This is the direct light, okay, and there is a light stop arrangement. This light will be stopped here. Okay. It will not reach up to the receiver. And so, we will stop here today. We will continue with this in the next class. Okay. Thank you.